All right. Hi, everyone. I'm Mike Giambalvo. I'm a developer with Google Cloud Platform. I work on the front end for it, which is probably the biggest Angular app at Google right now. My Twitter handle and GitHub is Heathkit. Heathkit app. Let's make this bigger. Is that big enough? Yeah, that's fine. I think the GVC froze. Well, that's great. Yeah. So this we're gonna be making an app. The point of this talk is you learn about Angular. When you first come into it, there's a lot to learn, right? All of these concepts, directives and components and services just get thrown at you like a scoop of ice cream just right in the face. And you follow the examples and you don't see sort of a real world practical example of how can you quickly get to something that you'd like to use. So that's the goal here, is we're gonna walk you through making a useful, simple Angular application, like how you can make a prototype that you want. So don't worry about following every step. It's kind of like a cooking show. We've skipped sort of the boring parts, and sometimes I'll just say, oh, I forget how to do that, or this is taking too long, and I'll just like, boop, go to the next thing. It's a broad area, so there's gonna be lots of different topics, although I'm gonna try to keep it focused on just a few key areas. And everything for this example is up on GitHub. So on the GitHub repo, Angular-Seattle, IceCreamFight, you can go check it out now. But basically, everything here is laid out step by step, and there's 10 steps total. We've got guides for about 7 of them, and I'm going to be filling that out later. So you can come back there, and it'll be like a full tutorial from start to finish how to make this app. And the app is running, so if you want to go check it out, and I recommend you do that, IceCreamFight.firebaseapp.com. It should work on like phones, tablets, whatever. And if you do that, you'll be presented with this. So this is the app we're making. Oh yeah, there you go. There's different flavors of ice cream. You can vote on them live. Everything updates. You can't vote too quickly. I just need to see everyone like doing stuff. And you can also add new flavors. And I'm just gonna put this out there. There is a code of conduct, and I'm kind of like putting my trust in everyone in this room. You can push that button and you can add images to this list. So be responsible, or we're gonna have to, take away your ice cream. So what's new in Angular 4? So the reason we're doing this talk is because we did a talk on testing a few months ago, and a lot of people were kind of new to Angular 2. We're coming from AngularJS, wanted to learn about it, or some were just new to web development. So if you're used to AngularJS or Angular 1.5, 1.6, everything's new. So it's very different. Everything's in TypeScript now, and there's some good reasons for that. There's a CLI tool to help you set up a project scaffold really easily. It's centered more around component-based design. So whereas in old Angular, you might have had model view controller and then a scope that's passing the shared state around. You don't do that now. You do components. And it works well with reactive programming, so RxJS. We're going to learn a little bit more about that. Finding good help on these subjects is hard, especially now because we're in this period where we really want things to be called AngularJS for the old stuff and Angular, just Angular for the new stuff. The Angular team is committed to periodic releases. So Angular 4 just came out. Angular 6 is coming out in 6 months. Angular 8, 8 is coming out 6 months after that. And the reason is so that you have a predictable release schedule, you know when things are getting deprecated, you get notified of a breaking change, but means you can't just go around saying Angular 2 all the time, because that's increasingly inaccurate. However, if you're Googling around for stuff now, you do have to use like Angular 2, like Angular 2 data table, Angular 2, whatever. If you see like Angular 1.5, Angular 1.6, AngularJS, that's not what we're talking about. The easy way to tell, is it in TypeScript? It's Angular. Is it in JavaScript? It's AngularJS. If you're in the domain angular.io or material.io, you're in the right place. Avoid anything that mentions beta. There's not going to be a beta Angular 6. It's just going to come out, and it's already like in there. So anything with the name beta in it is old information. And Google tip from Jens, you can filter by date. So you can give Google a date range. And that's a good way, if you get the Julian date, to restrict your search, so you'll get better results. So if you just Google like Angular stuff for the past year, you're guaranteed to get like Angular 2 and beyond. What we're doing today, so it's the 2017 annual Ice Cream Expo County Fair exhibition, and we're going to be designing the voting app for them, right? So that's the app that we showed you earlier. And so the requirements are, it has to, we have a list of ice cream flavors. People can vote in real time, as you saw those live updates coming. Anyone can add flavors, and we restrict how fast people can vote, because you don't want people to just spam the button, right? You want them to vote at a certain, no faster than a certain rate. So this is what the full guide covers on GitHub. If you're interested in all these topics, go there. This is what we're going to cover tonight so that we go to bed on time. So let's go ahead and get started. So why are we doing this app in Angular? One of the nice things about Angular is it's kind of batteries included. There's a rich collection of documentation and tutorials, and there's fewer decisions you need to make to get on your way to doing code. If you need to use a router, use the ng router. If you need a good UI library, use material design. And the team is working more and more on giving you sane defaults and choices that'll work out of the box, which means you spend less time like Googling and hunting down for the right way to do something, and you just get started. And also compared to AngularJS, the tooling support is great. I'm going to see some of that tonight. Part of the reason the tooling support is so great is because of TypeScript. So TypeScript, how many people have used TypeScript or are familiar with it? Okay, we'll just kind of blow through this a little bit. As you know, TypeScript is JavaScript next. So it is not a new language, but it implements what will become the JavaScript standard. And it's JavaScript with types. Lots of editors support TypeScript because of the way they implemented it. You can use IntelliJ, Atom, or Vim, but the best is VS Code as of now. I'm partial to Vim myself. I use Vim a lot, but I would use IntelliJ if I needed like a fancy editor. And IntelliJ is great, and they have a great Vim plugin, but the VS Code Vim plugin is finally good now. So I like VS Code. And if you need to get started, Angular.io guide quick start will take you through like getting Node.js, getting NPM, all that good stuff. Angular CLI. So as we saw earlier in Tara's talk, it sets up a whole project for you. So you don't have to configure Webpack. You don't have to set up your scaffolding. It has generators for common tasks that you do. You don't have to figure out if you're using Grunt or Gulp or Yeoman or whatever. You just do your thing. Just do your app. Don't make your build system. And NPM 5 is better. So be on NPM 5, especially if you're using the latest Angular CLI. That's important. So this is what we're going to do, right? Install the Angular CLI. And we're just going to, we're not going to do the almost live coding. We're going to do like the real live coding, which is not a good idea ever, but we're going to do it. So ng new IceCreamFight creates all these files, right? All the scaffolding. We can go there, and then we do npm install. And this is one of those cases where we actually have the pre-baked version because this is fast, but it's not quite fast enough. So this is a version that I made earlier. And this is what you get out of the box. So it runs this ng-serve command, which is going to start a dev server, put up my app, and it's going to set up live reload in the browser too, which is nice because it means when I get this default, I can come in here to my editor and I can change this template. And as I save, it'll rebuild and then live update. You can see right there. So I can delete it and it'll just go away. So that's ng-serve, right? We're already a lot of the way there. We have an app that we're building. We're off to a good start. Don't be intimidated by the initial scaffold. There's a lot of files in it, but really, like as Tara pointed out earlier, that's all you need. There's basically, you're going to do everything within source or a source app. And everything else is just kind of scaffolding set up for other tools. Also with Angular CLI, there is an eject command. So out of the box, you're not configuring Webpack, but if you build your app and you scale it to a point where now you have to configure Webpack, you can do ng-eject. And they take all your config files, they dump them out for you, and you're on your way. But you can't use the CLI after that. You kind of leave, you eject, so you don't get back in. We just did that demo, so we're good. we're going to talk about some basics of Angular now. How many people are familiar with AngularJS? And like, how many people are familiar with Angular? Angular 2 and beyond. Okay, so don't spend too much time on this, but we're just going to go over basic concepts. So the most fundamental concept in Angular is a directive. And this has a somewhat different meaning than it did in AngularJS. So in Angular, a directive is a class, and when I say class, I mean like object, like a class in TypeScript, that changes behavior or appearance of an element in the DOM that matches a specific selector. So here's an example of a directive. I'm defining this class called highlight directive. Here I have an annotation. So this is something TypeScript gives us. This is not JavaScript. We can apply annotations to classes and functions. And that's one of the ways Angular integrates a lot of its functionality, is with these annotations. So I'm saying this class is a directive, and this selector is what it'll be used to match to the page. And then here's an example of my template. So this selector is an attribute selector, actually. So it's the brackets and then a word in that's searching for HTML elements with that attribute. So in this case, I've given my paragraph tag the my highlight attribute. And when Angular is going to compile, it's going to match that selector against the document. It's going to see there's a DOM element that matches that selector, and it's going to apply this logic to it. And this logic is to make the background color yellow, just highlight something. So if that goes to the Angular compilation process, this is what happens. This template becomes this output. Pretty simple. A component is also a directive. It's just a directive with a template. So components are now how you express your views. Components are nested in a hierarchy throughout your app. So a component is applied to an element of the DOM, injects its own template, its own view, and it may itself contain other components all the way down. A component is composed of a view, that's the HTML, a component class, so this is the singular class that controls, it's sort of the controller actually for that, and then styles, CSS. The nice thing is it's not really Shadow DOM, but it's kind of Shadow DOM in that these styles are isolated. So whatever is in this file only applies to this template, and whatever's in this template only applies to this component. It's all sandboxed in namespace, so you're not going to have global conflicts or anything. You can use whatever names you want. So here's an example of, there's an example of a component. Once again, we have a directive here saying that this class is going to be a component, and we have a selector because this is a directive and it needs to know where to apply to in the DOM. And it has a template because it's a directive with a template. Okay, we did it. And this is what happens. This is the template. Angular compiles it, renders it out to this HTML. So in this case, the template is just this opening phrase and then this hello world element. And then this selector here matches any element with the name hello-world. So Angular says, oh, okay, I'm going to take this element, I'm going to take it out of the DOM, I'm going to put in that template, and I'm going to have a component instance manage it. And when it does that, this is what the HTML looks like in source, and this is what gets rendered to the page. These templates that we showed you, they're evaluated in the context of a component instance. So what that means is this class here, Angular is instantiating it, and it's instantiating it one per whatever it finds, per DOM element that it finds. So there'll be many of these component instances with their own private state throughout your app. The templates can be defined inline or in a file. So here we did an inline template, but you can also just have like a separate file with your template. So you can have a file that's just HTML, which is handy for like big teams with like designers and stuff. It's fully contained within the component. So before with AngularJS, you would have a scope, right? And you make changes that might propagate up and down the scope. And that's not the case here. So everything that happens in your template stays in your template. And unlike AngularJS, these templates are compiled. So what's actually happening is Angular is taking this template and your logic and your selectors, and it's spitting out rendered, optimized HTML. And part of that means that you're actually getting checks at compile time. So if you've used other like web programming languages, if you used AngularJS, you might have a template expression and you like have a typo or you do something wrong and you're like, well, why isn't this working? It's O because it's spelled that way. And you'll actually catch that now when you build your app. You'll get an error rather than having to catch it at runtime. So here's an example of how a template actually works. So this is a template, right, for this photo component. It's a template URL, meaning it's specified in a separate file. It's down here. The selector that matches it is photo, so this is going to match any photo element in the document. And this class defines a method, change photo, and it has two properties, a message property and a photo URL property. Within my template, these template expressions are all in the context of this component. So what that means is, here's string interpolation. So this says take the message property of my component instance and render it as a string and put in the template. Angular live updates, so it does change detection and everything. So if I had logic here that was like change the message every second, make an HTTP call, do something, that would update in the template. I don't have to do anything else. It just updates live. This is a property binding. So this is how I would take a property from my component and turn it into text in the document. If I want to apply it to the attribute of an HTML element, like in this case, change the source attribute of this image tag, then I put these brackets around that attribute. And then this is going to go to this component instance dot photo URL. And it's going to take whatever this property is, insert it here. And again, this live updates. So I can change this URL and I can point to different photos. This is an event handler. So that's how you get information back into your component from the template. So what I'm saying is, for this button's click event, I want you to call this method. In this case, it's calling the change photo method, and it's passing in a $event, which is like a special substitution variable that's just the event object. So now when I click this button, change photo is going to get called. It'll get past the event, and it'll update message. It'll update live. Also important to know about are services. So if you're familiar with AngularJS, this is going to be familiar. It's a singleton instance that's shared among objects in a model. We're going to talk about what models are in a bit, but the key thing to keep in mind is a service is Angular is going to instantiate it for you, and there's only going to be one typically. What Angular does is it wires all of your services together into your app for you using dependency injection. So if you come from a Java or a C# background, you've probably seen a dependency injection library before. AngularJS had dependency injection, but it was really kind of weird to use because you had to do it by strings. You had to say what kind of thing you wanted, right? And what you'd rather do with dependency injection is say, I want a class. I want this kind of class. And of course, you can't do that in JavaScript because you don't have types. But in TypeScript, it's in the name, we have types. So what I'm saying here is, rather than me having to call new on this service, I'm going to define my constructor and say that I take a parameter with the class myService. Angular will instantiate my component. It'll instantiate that service, and it'll feed it to me when it constructs me. And the advantage of that is that I'm not tied to this implementation now. Anything that implements this interface I'm expecting, my component can use. This has lots of uses. The big one is for testing, right? So if I wanted to make a test for this component, I would have to come up with a way to like change out the service here. But if I'm using dependency injection, I can just tell Angular, hey, if you want a my service, use the fake one. And it'll spin up my component and give it the fake service. And a little like note about TypeScript shorthand, you're going to see this a lot. It's confusing somewhat, but it's nice. Here you can see in this class, I have to define a property with a type, and I have to have a constructor, and then I have to have this dot whatever is equal to this. You don't have to do that in TypeScript. If you give it an access modifier, it automatically assumes that's a property on your class. So it'll make this a public property called service with this type. I could also say private. But if I don't say anything, then it doesn't do that. So keep that in mind. And here's how you make a service. So you make a class. It's just a plain old JavaScript object or TypeScript object. But you put this injectable annotation on it. And that tells Angular, hey, you can use this for dependency injection. And then to use a service in your component, you just put it in your constructor. And then Angular takes care of wiring it together for you. So the thing about dependency injection is you're telling Angular how to satisfy dependencies. And at some point, you need to hook everything together and say which components, which specific services, which directives you're using. And the way you do that in Angular is with a module. So this is kind of an overloaded term, right? There's ES6 modules, there's TypeScript modules, but there's also Angular modules. And the way to think of them is if you're familiar with Juice or the dependency injection frameworks, those typically have like a module associated with them too. And that's what this is. So again, we use the decorator. Decorators have to be applied to a class. So sometimes we will just have like an empty class here because there's nothing useful to put in it really. Although we could give it a constructor and other methods if we had to. But I declare a module. I say what components this module defines. I can import other modules. So I can make a module that exports components. So if I have a collection of components I want to consume, I would import its module. And then I also list out the services. So this is where I set up providers. And Angular's dependency injection tool is actually pretty rich. And this provide string can be more complicated than that. So if you in AngularJS use like factories and stuff like that, you can do that here still. But this is like the simple way to do it. So that's it. That's basics of Angular. And I don't have a time up here, but I guess we're doing okay. Oh, that's nice. Yeah, the thing here froze. That's not good. So in a lot of these tutorials, they'll tell you how to follow and write an app, but they don't tell you like how to really get started. Like you have an idea in your head and you want to design it. So in this case, this is the idea that we want. We have a really simple app. It's 2 views. It's one view that's a list, one view that's add. This is what we're trying to accomplish. So how do we start designing this? Well, Angular is component-based. So the first thing you do is you determine what your components are. There's always going to be an app component. That's sort of your root level component for your entire app. In this case, the app component includes my title bar. And this is a button that takes you back to the home screen. So like navigation. You can also put like menus or login or stuff like that here. And then here's a child component with the ice cream table. So here's all the flavors sorted by votes. This is this is the same component actually. And it's using the router that we saw earlier to display a different component in its content. In this case, it's just a form where you can add new flavors. So as we said before, an Angular app is a tree of components, and this is what that tree looks like. So I have my app component that I define, my flavor form, my flavor list, and the router outlet, the buttons in the table. That's all stuff that I use, that I just import in and reuse. If you want to use material design, because that's how we get this attractive looking table, you just npm install Angular material and Angular CDK. We'll get to what that is in a bit. And we're also going to add some Angular animations. So we do npm install save Angular animations. And we're also going to be generating a component. So the Angular CLI can create the scaffolding for us. And the goal is to get this material design data table running. We're going to display some static data. So rather than having to make a server request, we're just going to have this here in our component. One last concept to cover is what is an observable. So you've probably seen, how many people are familiar with observables? Okay, so this isn't new, right? It's like a promise. There can be many of them. The way I think of it is it's a reference to a value that changes over time, or more appropriately, a stream of values. The material design table accepts an observable. It accepts an observable array, and that's so that it live updates. It expects an observable that will have a new value every time you want the table to change. So when we're using it, we have to give it when we're using this table, we have to give it a data source. And we're going to show what that is in a minute. So just to show you like how I would actually do this and how I actually did this not too long ago. So here's my app, right? This is the scaffolding that Angular generated for me. I'm just going to go ahead and get rid of the scaffolding. And just delete all this. Someone has helpfully put in a little snippet of HTML that I want to display. Someone has also helpfully already done the CSS because I do not want to do that again. So we applied the style. We don't have the font though. That's funny. And we're not going to have it. And now what I want to do is I go to material design. I'm like, okay, well, this is a good start. But what I really want is some sort of component that I can put up top. So let's go to the component library and toolbar. That sounds like what I want to use. Toolbar is a container for headers, titles, and actions. That sounds right. Here's the demo of material design. I can view source. That's how you use it in HTML. That looks easy. And here's the TypeScript to use it. That also looks really easy. So let's go ahead and use it. So say MD toolbar. We close it. And this example is actually pretty simple. You typically have to give them a span, but you just give it, a toolbar with some content. I save, and everything's broken. Why is everything broken? Yeah, I know this is going to be broken. I'm just like taking you through it. It doesn't know what the toolbar element is, right? So my app isn't aware of what the toolbar is or where it comes from, and that's because I haven't imported it to the module. So let's go ahead and do that. One kind of handy trick is we're going to be importing a lot of stuff from Material. Material puts every widget they have into a separate module, which is convenient. But what it means is that we don't have, we have a lot of modules that we end up importing. So we create a sort of a sub module. And this will import, in this case, MD toolbar. And now I need to import it as TypeScript. Maybe you can see this error. Failed to compile, right? So now it's failing to compile because my JavaScript is wrong because I don't have that. So now I will import the IceCream material module in my imports for my ng module for my application. And this might be one of those times where we skip ahead. Oh, nope. Handily, because when VS Code, we see that we forgot something. So we're importing the toolbar module from Angular/material. And that is not working. So we're going to skip. This is where you skip to the thing where you wrote the app a few hours ago, and you look up how to do it. Okay. And I'm going to just skip ahead because I think I haven't actually npm installed something I should have. I said earlier, you have to install, save Angular material. So we're going to let that run and then come back. And serve it up again. And then this is actually running Webpack. It's starting up the Webpack development server, like all that good stuff for us. And if we save now, TypeScript should know that we know what we're doing and get rid of the red squigglies. Oh, and it needs Angular CDK. So let's go ahead and get that too. Let's go ahead and add the CDK module. I'm going to look at what that is. Yep. Okay. What is CDK? So if you look at the Angular material documents, you'll see references to CDK in the guide. And this stands for Component Dev Kit. So what this is when they were making the data table that we're going to use, a data table has a complex API, right? And if you want other people to be able to make data tables, you want to have like a standard API that conforms to. So the CDK is sort of the base API for these extra components apart from material design. So theoretically, if someone comes up with a different design language than material, if they make it CDK based, you won't have to change too much. You'll just plug it in and you'll get this other behavior. Part of the reason for that, oh, this is easy. Part of the reason for that is because one of the core ideas of Angular is it's a rendering agnostic tool. So the idea is you can render to native, to VR, to whatever. It's not just about web. Okay. I need to export it and I need an S. Both of you are correct. Hooray! Okay, that was not worth it, but we did it. That's what matters. I'm just gonna double check. Yeah, well, this is a toolbar, so that was fun. All right, we're gonna move along. So if I had done that whole thing, so you do all that, right? You get the table, you copy it in, you configure everything, you wait for Webpack to build, and what you end up with is this asset optimization is always the last step. A basic table. So we have a toolbar, we have a material design table. We click the buttons and nothing happens because it's just static data. So the next thing I want to do is actually display live data, have people vote, have it update in real time. And an easy way to do that is with Firebase. Firebase is a collection of easy to use tools, one of which is a real-time database. It also has other neat features like authentication and cloud functions that we're not going to use today, but you can look them up. And the other nice thing that they have with Firebase is free hosting, which is how this app is actually hosted right now. So it's great for prototyping because you don't need to set anything up. If you go to firebase.com, someone's hopefully registered that and they tell you that you're looking for actually Firebase. So it's kind of handy. There is no Firebase company. It's just a good citizen. To talk to Firebase from Angular, there's two modules you need, Angular Fire 2 and Firebase. We install, save those, we set up their modules, and that gets us the actual Firebase client. Then we can generate a service. So again, this is where we're going to put the logic to actually talk to Firebase. And I'm just going to show that off real fast. So in this case, I've done ng generate service, and that's given me this flavor service. I marked it as injectable, and I've given it two methods, get flavors and add vote. These are calling into Firebase. It's injecting an Angular Fire database, and I'm listing the flavors, querying them. You can look up how to use Firebase later. I'm taking the result, and I'm actually mapping it to a function that'll reverse it. Because if you get it sorted back from Firebase, it'll actually be sorted low to high, and I want it sorted high to low. So that's why I reversed it. If I look at my IceCreamTable component, this component has a data source. And the data source is what you give the table. So when you load an empty table, one of the attributes it has is the data source that it's going to use to display data live. So in this case, the data source is a new flavor data source that I've created, and I pass it the service that talks to Firebase. The data source is just a class that implements this data source interface that can connect and can disconnect. So the table starts up, takes the data source, it connects, and it gets an observable. If I just wanted to do static data, right? So this is live. This is the data from Firebase. If I just wanted static data, I could just do right, and then some like static data from earlier. There's nothing. So you know, you can have an observable that's just a static constant value. All right, so now at this point, we have our data from Firebase. It's everything showing up live. We can vote. Stuff shows up. This is great, but people can vote too fast, right? One of our requirements was that we rate limit in some way how fast people vote. And there's lots of ways we could do this, but this is also a good chance to use reactive programming because our data from Firebase is coming in as a stream. So what is reactive programming? If you haven't heard of it before, there's a great article called "This is the Introduction to Reactive Programming You've Been Looking For." It's the one with the dog saying everything is a stream. That's a really great overview. Anytime you learn about reactive programming, you're going to see these marble diagrams because, as we said, an observable is a reference to a value that changes over time. And each of these little marbles, each of these circles, is a different state of the value or a different event. This timeline is time, moving left to right. These are different click events that can be represented. This could be a stream of strings, of objects. For our table, it's a stream of arrays. And it can also be errors. The reason this is useful is because you can take these streams and apply operations to them that change how they behave. Sort of with functional programming, how you compose functions to achieve different behavior. So the behavior we're trying to achieve is we throttle the rate at which events go through. So let's say we take our clicks, and right now what we're doing is in our ice cream table component, this button right here, this vote button, is calling the addVote method on our component instance and passing the key or the ID, the flavor you're voting for. And that's calling this, and that's invoking the service, and that's how the vote count updates. Instead of calling this, invoking this callback, what we want to do is create a stream of events that we can then manipulate. And if we do that, we have this throttle time operation that we can apply to the stream right out the box that'll throttle how fast it passes events through. And if you go to rxmarbles.com, they have nice little interactive demos that sort of show you what these different operators do and what they mean. And you can sort of play with them live. I think I might just skip ahead because we're almost out of time. Nope. And I lost my presentation. There we go. So if we let's actually just skip to the end. So here we've gone and done that, right? So we create a subject. So a subject is a stream that you can write to as well as read from. So it's a subject that you're going to be listening to. I create a subject with vote $. $. is a convention that lets me know that variable is an observable or is a stream, which is kind of handy. Now what I've done is in addVote, instead of calling the service directly, I push this event onto the stream. I say vote $. Next. And in my setup, in my initialization, I get this subject as an observable, right? Because you can just turn a subject into an observable. And then I apply both GroupBy and Throttle Time. And the reason that I do that is if I just, let's say I just did Throttle Time, right? So let's say I just did this, and I'll make the delay more clear. I get the ID back, call my service. Oh, that was actually the wrong thing. Wait for that to build. So what I've done here, like just to show you, is taking my vote stream, turn it into observable. I'm throttling it, which is saying I only want you to emit events at a certain rate and just ignore them if they come in too quickly. I subscribe to it, which is where I set up the behavior that I want to execute as new events come in. And if I do that, yep, my app reloads. Oh, you added so many flavors. And everyone adhered to the, thank you. Thank you for that. Mostly. Now it's rate limited. right? Now I can't click on it too fast. But the problem is it's globally rate limited. I can only click on one of these at a time. And that's not what the behavior that I want. I want to be able to click on any button. I only want to be able to click on a specific flavor at a certain rate, but I want to be able to click on all the flavors quickly if I want to. So to do that, I use the GroupBy filter. So my stream is coming through as a stream of flavor IDs. And I'm saying group that into one stream per flavor ID, right? So now I'm creating a separate, and I'm not saying ahead of time how many streams I'm doing. I'm just creating one stream per event ID. So I say group by, in this case, the function I'm grouping by is just identity, right? Group by things that match. Subscribe to this stream, right? So what this is going to return now is actually an observable of observables, which is kind of a difficult concept to grasp, but it's really important because a lot of these operations end up transforming one observable into many. So what that means is I'm getting a new event, and what that event is giving me is something I can subscribe to. And that's what this is. This is an observable of click events for that ID, for that flavor. So I subscribe to it, I apply the throttle to it, and then in my subscription, I upvote it. And now with that change, I can click on all of them in sequence, but I still am rate limited by how much I can click one. And you can see this rate limiting logic is not much code, and it's very much driven around the results. And that's the benefit of doing reactive programming, is you're kind of easy for you to make these transformations of events. You're defining your application in sort of an event-driven way. Right, so we're using GroupBy to divide the streams by row ID. And again, the slides have like specific examples of the changes that we made. All right, last step, deploy. So this is the advantage of using Firebase, right? You can globally install the Firebase tools in your application, call Firebase init, set everything up. There are guides to tell you how to do this, but basically this app that I created at the start with ng-new, in addition to ng-serve, which is what I use for development, I also have ng-build, which builds my app, compiles it. So when I've been running it, I've actually been running it in dev mode, but it's going to be built into, oh, I'm not in the right directory. What I'm actually going to be doing is building an optimized version of it. So your whole asset pipeline, minification, obfuscation, that's all set up. That's all done with Webpack. It's all happening right now. It's going to end up in the dist directory. And then I've configured Firebase to look for my static files there. So once this finishes building, all I'm going to have to do is Firebase deploy. And it'll copy my app up to my hosting on Firebase. And I can update stuff live. And that's how you get updates to IceCream app, IceCreamFight.firebaseapp.com. And just because I feel the need to, I'm going to prove IceCream get along well, because we're not fighting anymore. I just ng-build and deploy. And eventually we're going to see that just updated live. It's over. We did it. So this was a short, covering of all that. There's more. There's animations. Routing is in there. So go to the GitHub page, link from the slides, to see the full tutorial. And all right. Thank you. Thanks for coming. Thanks for coming the first one of these. Is that it? Closing. Just come on up.
Quick question, thanks.
Oh, yeah. We should have questions.
The sandboxing that you mentioned when you were talking about the Angular. Sorry, the sandboxing you mentioned, when you're talking about when you were in the code, and you're talking about the hooking Angular and hooking all of the code together. Mm-hmm. And then later on, when we're looking at the application itself, the sandboxing in the application, so that perhaps you If there was drag and drop enabled there, perhaps you wouldn't. Actually, there isn't drag and drop enabled, so there's no drag and drop because but also the application itself is sandboxed.
Well, it's not really sandboxed as much as it's just. So the sandboxing I was mentioning earlier, I think I was talking about components.
Yes.
And now each component is isolated. So in this case, in this ice cream table component, I have a style defined for it. So I have CSS here.
I guess my question is more, how many levels of sandboxing are there, and how granular is your sandboxing is as far as earlier on we learned about, or I learned about groups when we're looking at routes. How granular and specific is your object capability security?
There's different kinds of granularity. So there's for styles, it's contained within the component. There's also the module level. So services are shared within a module, right? So if I have multiple modules that all define the same service, they all get their own instance. If I need to communicate across modules, I can typically do so with fancier providers or with events, which we didn't cover, but events can go up and down the DOM. And that's how modules tend to interact.
Okay.
So if you have something that you want to be like a reusable component that you ship out, it's contained within its own module. It won't affect anything else. It won't interfere with the client styles or the client objects. It just communicates with events.
Okay.
And that's kind of the area we didn't cover is that property bindings that we had earlier. You're creating components that can have custom properties and emit custom events.
Okay.
Right. So if you have something that's communicating across modules, it can emit events to its parent components.
Okay.
And it can also change the properties of the parent can change the properties of the children.
Okay.
So that's the only thing that's not sandboxed, is the tree, the component tree structure of the app. You can pass events up and property bindings down.
Okay. Okay. Thank you.
Anything else? Other questions?
More of a TypeScript question, but do you know if you can reference an absolute path instead of relative paths when importing like your own components and things like that? Or does everything have to be relative paths?
Everything's a relative path. And if you're coming from, so one of the things people ask about sort of style and best practices is like, where do I put my tests, right? So that's something else that you might have noticed is the Scout ngCLI is generating a spec, right, with every component. There's not a separate test directory. And the reason for that is you import in TypeScript with relative paths. So if you had a separate test directory, all your imports would look like ... full path, whatever. Whereas here, and I actually have a test, this is in the same, this is a relative import of this. So that's how the modular resolution works in TypeScript, is either it's a relative path and it's a .ts file, or it's a module name. And then the absolute paths are module names, basically. That's what I'm saying.
Unless it's relative based on the application.
Right.
A route, because you can specify a relative path which will be fixed, so you can safely move your component wherever you want, but the relative path will still start with the app, let's say.
Are you talking about TypeScript modules or
TypeScript modules?
Okay.
You don't have to use ... necessarily.
Okay, you can just define what everything's relative to.
So it's kind of absolute path, but it's still relative within the context of your application structure.
Okay.
Which is helpful if you want to move your component, if you want to be able to move your component from one place to another. Your ... will not have to be modified, but it's still relative.
Okay, that's good to know. Cool.
Other questions? Cool.
All right.
Thanks for coming.
Yeah. Thanks for coming out.